Hello everyone, welcome back to another kinetic tutoring episode. Today we're taking a look at the first FRQ of the AP Calc BC exam from 2023. So let's get straight into it. A customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by a differentiable function f, where f of t is measured in gallons per second and t is measured in seconds since pumping began. Selected values of f of t are given in the table. Part A asks us to, using correct units, interpret the meaning of the integral from 60 to 135 of f of t dt in the context of the problem. Use a right Riemann sum with the three subintervals 60 to 90, 90 to 120, and 120 to 135 to approximate the value. Alright, so when we take the integral of f of t, which is in gallons per second, we're essentially getting rid of the per second, because we're seeing if a certain amount of gallons per second is added over a certain amount of time, the area under the curve becomes the overall amount of gallons. So the integral would be the amount of gallons poured into the amount of gallons of gasoline poured from 60 seconds to 135 seconds. And so let's do this Riemann sum. Let's draw our graph first. Okay, so we have the point 0, 0 at 60 seconds, which we'll put here. We'll call this 60. It's at 0.1. At 90 seconds, it's at 0.15. At 120 seconds, it's back at 0.1. At 0.05 or rather at 135 seconds, it's at 0.05. And at 150 seconds, it reaches 0 once again. So what it's asking us to do is, with the three subintervals 60 to 90, here we have 60 to 90, using a right Riemann sum, so we use the right value here. We make a block, and this is one of the areas that we add to the sum. And then we have 120 as well, which is 90 to 120 is right here, this area of this block, and 120 to 135, so the area of this block. And so here we have the three boxes that represent the three areas that we're going to be measuring. So now let's calculate the area of these boxes. The area is just going to be base times height. From 60 to 90, the base is 30, and the height is going to be 0.1. So the area of this box is 3. This box has a height of, it's 0.15 times 30, which gets you 4.5, which is the area of the first box. The area of the second box is going to be 0.1 times 30, which is going to give you 3. And then the third box is going to be 15 times 0.05, which gets you 0.75. So these three added up together, this gets you 7.5 times plus 0.75 gets you 8.25. And this is going to be in terms of gallons. This is our estimation using the Riemann sum. There you go. So now let's take a look at point B, or part B rather. Must there exist a value of C for 60 where from the interval 60 to 120, such as f prime of C is 0? Alright, so we know that f of t increases and then decreases, and we know that when f of t increases, that means that f of t is positive. So f prime of t is positive, so f prime of t is positive here, and it decreases here, so f prime of t is negative here. So in order for something to go through from positive to negative and be continuous, which we are assuming it is because here it says differentiable, and in order for a function to be differentiable, it needs to be continuous. It needs to go to 0 for it to go from positive to negative. And for this reasoning, f prime of c is going to be 0 between 60 and 120. The rate of flow of gasoline in gallons per second can be modeled by g of t is equal to t over 500 cosine of t over 1200 squared for the interval 0 to 150. Using this model, find the average rate of flow gasoline over the time interval. So here what we're going to want to do is to use the average formula, which is 1 over b minus a integral from a to b of whatever formula you're using. In this case, it'll be g of t dt. So from here, you're going to need to use your calculator, or you could solve it by hand, but it is much simpler to use your calculator. So you go to your calculator. First, we're going to calculate 1 over b minus a. We know that b is 150 and a is 0, so 1 divided by 150. And then you do that times your integral. And in case you're not sure how to get to the integral screen, what you want to do is press math and then 9. And then set your bounds as 0 to 150. Put in your equation, x divided by 500. You should use x instead of t just because t is not a variable option on calculators. So you get x divided by 500 times cosine of t divided by 120 squared, which you make x divided by 120 squared dx, and then you calculate that, and you get 0.1499. All right, so this means that the average rate of flow is going to be 0.1499, which makes sense because it's under our max value and it's over our minimum value, so it's within the range. It's not a ridiculous answer, so there you have that. Or sorry, 1.4998. I'm gonna add that last digit because if I don't, I would have had to round up to 0.15 rather. So there you go. And yeah, the way you would have done that is 1 over 150. This is how you would show your work. 150 g of t dt. And now part D is asking you to use the model G defined in part C to find the value of G prime of 140. So once again, you can use your calculator for this. You're going to go math 8, that's where the derivative is, d dx, and then you put in the same equation of G. And another way that you could have done a simpler way you could have done this is to set your equation as to y1 so you don't have to type it in twice. Unfortunately, I forgot to do that, so I'm going to type it in again. So let's see what we get. We're going to get the slope, or the G prime of 140 is 0.001997. And what this means is that this is going to be the rate of change of the rate of flow of gasoline basically the second derivative of f of t, because g of t is the derivative of f of t. It's the rate of flow, so you could say this is f double prime of t, or the rate of change in the rate of the flow. So there you go. That's what you would get. If you want the terms, it's going to be gallons over seconds squared. So there you have it, guys. That's how you would go about solving this problem. I hope this video has helped you. If it has, please consider subscribing to the channel and pressing the like button. It greatly helps. And if you have any comments, questions, or concerns, leave them in the comment section below. I'll try my best to address them, and I will see you guys next time.